All right, this is another gate-enabled flip-flop. So the values of D are only going to pass through in these areas where the gate itself is enabled, and in the areas where it's not enabled, we're kind of going to ignore what happens to it until it comes out of being enabled. So there's a little bit of a fine line that we'll have to go through in a couple of places here and here, but not too much. All right, so the value of Q will, because it's enabled here, will follow the data, and the data is low at this point. So it's going to go into here, and then the gate itself becomes disabled, so it'll pass through there in that same form with the flip-flop holding that value. As soon as it comes out of there, it senses that this has gone high, so it'll go high, and it'll follow that D value as it goes through the enabled state, and then it'll go into the non-enabled state at this point. And then when it'll come out of there, it's back from being low to being low again, so it completely ignores the fact that there was a 1 there to begin with. Comes out of there, it's still enabled, so it follows the enabled data to set this back up again, and then again goes through this region where what happens really doesn't matter. As soon as it comes out of here, this is where it gets a little bit fine line-ish. As soon as it gets out of here, this becomes enabled. It senses that it's gone low and begins to follow that around all the way over to where it becomes disabled, at which point it doesn't change, so it kind of goes out of there flat, kind of like this one does.